Welcome to April 13th LeetCode challenge. Validate stack sequence. Given two integer arrays pushed and popped, each with distinct value, return true if this could have been a result of a sequence of push and pop operation on an initially empty stack, or false otherwise. Example 1, you have an input of push right here, given as this array of integers. You have input of popped, given this array of integer. You want to know whether the resulting array could have been made due to a result of sequences of push and pop operations. And the answer is true, because in order to get, say for instance, from push to popped, if we were to push 1, push 2, push 3, push 4, and then push 5, then actually no, not push 5. We could push pop 4, then push 5, then pop 5, pop 3, then pop 2, then pop 1, and therefore we'll get the sequence right here. That's pretty much it. Example number 2, push then pop, given this by this array here. The answer is false, because 1 cannot be popped before 2. So if we were given the sequence here, if we were to pop 1, we cannot pop 2 afterwards, because 2 is basically after 1. There you go. Our constraints of push length is between 1 to 1000. Push at index I is 0 to 1000. All elements of push are unique. The length of push is equal to the length of push popped. Popped is permutation of pushed. So basically, these arrays have the same size and length, and they're just the numbers just are unique, and that means that they are just mixed permutations of each other, and we just got to determine whether they are a sequence of push and pop operations or not. So intuitively, it is a stack type of approach. Therefore, we can apply a greedy type algorithm. We have to push all items in order. So how do we pop them? Say we have a stack where we have 2 at the top, right? And then we want to pop the next value. How do we do that? Well, that's because any subsequent pushes we make to the top of the stack will be different from 2. So we'll never be able to pop 2 after again. So that means that if 2 is on top of the stack, we can never get anything underneath it if it looks kind of like this example. So if we know the counter example, we can develop a sequence that, let's say, develop the algorithm for each value. We push in the stack, then we greedily pop the value into the stack if the next value to pop. And then we just check to see if we have all the pop values necessary in successful order. So in order to do that, we need to develop a integer, call it n, and that's going to be the size of the array. So let's just call it push.length. Next thing you want to do is initiate a stack. These are integer arrays, but at the end of the day, we are dealing with stacks, so it might be intuitive to use a stack of integers. Integers. Call a stack, and it's going to be a new stack. Next thing you want to do is initiate a loop of some sort for x. This enhanced for loop here, push. For each value x in push, we are going to push it into the stack. Stack.push x. This is using internal Java stack algorithm, or the data structure, I should say. Well, the stack is not empty. And j is less than the length of the stack, and the next stack element is equal to popped. So we want to do is stack.peek. I want to peek into the top element of the stack, and that's equal to the pop value at index j. So if all these are true, while all these are true, conditions are true, we want a stack.pop. pop the last item. And then we increment j as we go along. So that's pretty much the idea. We exit this while loop, we exit this for loop. At the end of the day, we should be able to return true or false, and that would be when j is equal to the size of our push length. Let's run this. Alright, so from what we can see so far, time complexity is big O of n, where n is the length of the push and pop stack. Either way, we can iterate through push. We can do the opposite, basically do the opposite as well by doing n equal to the length of the pop's length, and then we would just instead of push, we pop it, and then instead of pop the stack, we could push it right here. Space complexity is also big O of n as well because we have the length of the stack at most. Alright, that is it. Have a great day, everyone.